can have all the horsepower in the world, but if you can't transmit that power to the pavement, it doesn't do any good. This includes more than just sticky tires, but a bulletproof rear end housing and a strong set of axles to support the package. So when it came to putting a rear end in our project Max Street Nova and making it turnkey to support our Detroit Speed 4-link, we turned to Moser to build us a trick 9-inch rear end that can take more than enough of the 1,000 horsepower with a trick new Wavetrac differential. Project Max Street is our 1966 Chevy 2 that is powered by a supercharged 555 cubic inch big block fitted with low compression JE pistons, an F2 Pro charger, and a fast XFI fuel injection system. It will make around 850 horsepower to the rear wheels while maintaining total street reliability. That means we needed a 9-inch rear end that could perform perfectly on the street, drag strip, and autocross. When it came to designing the rear end that is going into Max Street, we turned to the build-to-order section of Moser's website. While working with Moser on our rear end order, we sent over our 4-link brackets from the Detroit Speed Quadra-Link kit. Moser has the ability to weld any additional brackets you may need to your rear end when ordering it. Simply supply the brackets with directions on where you want them. We went with their custom 9-inch housing that is constructed of seamless steel tubing. We selected the silver powder coating option for our housing as well. We chose their custom alloy 35 spline axles with a 5x4 3/4 bolt pattern to fit our billet specialty streetlight wheels on. Our center section came fully assembled with a bulletproof nodular iron case, Wavetrac differential, yoke, as well as the ring and pinion. The build-to-order rear ends also come complete with all bearings, hardware, and gaskets. One of the known shortcomings of a typical torque biasing differential is its loss of drive under zero or near zero torque conditions. The Wavetrac is the latest and greatest in differentials from Moser to help you overcome those one-wheel peel problems. The Wavetrac uses converging diverging wave profiles that are placed on one side gear and its mating preload hub. As the two side gears rotate relative to each other, each wave surface climbs the other, causing them to move apart. This imparts an increased normal force through the side gears, increasing the bias ratio as a function of load. This increase occurs automatically only when conditions find it necessary, and it reverts back to its nominal bias ratio quickly and seamlessly, maintaining optimal drivability and performance at all times. It's like having two differentials in one. You get the benefit of a higher bias ratio when needed without detriment to the car's handling. Installation was simple and straightforward. First, we installed the studs that hold the center section into the housing. The nodular center section installs directly onto the studs with a supplied gasket. Since we plan to drive the Nova on the street, we opted for Moser's parking brake assembly. Once the axles are installed into the housing, the retaining plates then secure the axle and parking brake assembly to the housing. With the parking brake assembly finished, we began installing the Moser 9-inch onto the Detroit Speed 4-link. The brackets we supplied to Moser lined up perfectly, and it was as simple as installing the 4 links, panhard, and shocks. Having the ability to send our 4-link brackets to Moser was a big help. They're able to custom tailor their housings to a variety of widths for virtually any application. With 1,000 horsepower on tap through our big block Chevy, we're looking forward to seeing how well the Wavetrac differential hooks up at the drag strip, as well as handling the power during turns at an autocross.